So one of our big topics we're going to talk about today, we're going to be talking about rates of change. And one of the big things we're going to talk about is being able to find the average rate of change between any 2 points. So we definitely have done average rate of change a lot, so much when you were in Math 1. But you were looking at lines, and those lines had a constant rate of change, right? They always had that same rate of change. So if we want to know the average rate of change between any 2 points on the graph of f of x, this is just the slope. Right. Through those 2 points. Now, we did that a ton in Math 1. Whenever you just had, like, here's the point 27 and here's the point 89, and what's the slope between those 2 points. So we did that a lot. It's going to look different in what we're doing here. So your average rate of change is just the slope between the 2 points. So the first thing you're going to do is you're going to find the, oh gosh, I got to look. Using somebody else's stuff. I got this one figured out, though. The notes out. I think I've got this one. Pretty sure I filled this out. Oh, find the y values of the function for the given interval. So, like, it's got a graph over here. Let's imagine that we were looking on the interval from -4 to 0, right? So -4 would be right here, and x equals 0 would be right here. You would need the y values to go with it, right? So, like, that would be -4. This one's actually, it's not the best example because it seems confusing where the, where they're all 0s and 4s. But you would need the y values that go with it. And then you just want to find the slope between these 2 points. This one, you could do slope formula, but you could also count it. What's the slope of that line right there if you just count rise over run? It's just 1, right? So that would be your average rate of change. I do not mind if you do this on your homework. He does this here. He calls average rate of change AROC, A-R-O-C. I do not mind if you do that on your homework, but you need to know that that stands for average rate of change. On the AP exam, do not abbreviate that. Right, average rate of change equals 1. Because there's no guarantee that they're going to accept that as an official abbreviation for that. And it is not worth risking your college credit for this class for the 2 extra seconds it takes to write that out. So write it out. Now on your homework, it's okay, as long as you know what it stands for. All right, so let's look at what we would do from an equation. All right, so I'm looking at this equation from -2, and if it says on -2 to -1, that's an interval. Those are your x values, right? So we're looking from -2 to -1. How do I find the y values that go with those x values? If I want to know the y value that goes with -2, what would I do? Just plug it in. That's all you got to do. So if I want to know the y value that goes with this, I will do f of -2, and it is very good for you to label that f of -2. You're plugging in -2 is what that's telling you there. And so be careful with this because it gets a little tricky here. Only the x is replaced with -2, so you still have that negative right there, and you'll have -2 to the 3rd power plus 3 times -2. And this sort of stuff we want to be doing without the calculator because it's probably going to be on calculator inactive. So if we do this, what is -2 to the 3rd power? -8. So we've got negative negative 8. And then 3 times negative 2 would be minus 6. What is negative 8? Positive 8. And you're welcome to do that part in your head. When it comes to AP exam, they don't care how much work you show on this. If you can do the whole thing in your head, that's fine. But be careful. I'm gonna show probably more work than not, especially when I'm doing the notes so everybody's following me. But if you skip straight to that this equals 2, that's fine. It doesn't matter if you show like small arithmetic steps or not. They're going to assume you can do that in your head. Now it does matter that you show you plug the number in there. So what this means is that I plugged in negative 2 for my x. I got out 2 as my output value, so that's my y coordinate. So this point is negative 2, 2 on the graph. So we're going to hold on to that. We need to know the other point. We got negative 1, so we're going to do the same thing with our negative 1. F of negative 1 is going to be negative 1 to the third power plus 3 times negative 1. And so that negative stays there. Negative 1 to the third is negative 1 minus 3. So that is going to be positive 1 minus 3. So I'll get negative 2. So for this one, I plugged in negative 1. That was my x coordinate. I got out negative 2. That's my y coordinate.
Does it matter which order they're in? Could it be negative 2, negative 4?
No, it cannot. So yes, it does matter what order they are in because the number you plugged in is your x coordinate. So it has to be first. And then the number that you got out is, well, let's see. The numbers are messing. Within the coordinate point. So like I could not switch this to negative 2, negative 1. That would be wrong. What doesn't matter is which one of these two problems I do first. So if I want to do f of negative 1 first and get this point and then do this one and get this point, that is fine. But as far as those coordinates, what the number you plugging in is your x coordinate. The number you get out as your answer is your y coordinate for that. So you can't switch these two values right here. Like this cannot be positive 2, negative 2. That would be wrong. But the order that you find these two doesn't matter. Okay, so now that I've got 2 points, I can use my slope formula. And that slope formula that you learned long ago is y2 minus y1 over x2 minus x1. It's up here, right here. So you subtract your y's on top, subtract your x's on bottom. It doesn't matter which point is x1, y1, and which one's x2, y2. You just have to be consistent in what you choose. So like normally people do this is like x1, y1. This is x2, y2. If you do it in that order, you will get negative 2 minus 2 over negative 1 minus negative 2. And so in the top, you'll get negative 4. In the bottom, that minus the negative 2 becomes a positive right there. So you're really doing negative 1 plus 2. And you'll get a 1 for that. So we would just get negative 4 for our average rate of change. And because I'm running out of space, I'm going to call it a rock. But we're not going to do that on the exam, just here. Now, I want you to see this on the graph, and I told you you can't use Desmos, but Desmos is just so much prettier. So I'm going to use Desmos here just to picture what's happening. Because, again, one of the big things we want to look at is those multiple representations. We want to see the graph and the equation and the points and see how that all goes together. So if I do f of x equals negative x to the third plus 3x, that's what the graph looks like. And then if I graph the point negative 2, 2, you can see that's this point right here on the graph. And if I graph the point negative 1, negative 1, negative 2, that's this point on the graph. And when you find the slope, you're looking at the slope between those 2 points right there on the line. which is down 1, 2, 3, 4 to the right 1. Right, so you can see how those relate to what you're looking at on the graph. Now, it's the average rate of change. It is not the rate of change at every point, because that's not a straight line, right? But it gives us the average rate of change. For example, if you drive from here to Winston, and let's say it is 50 miles and it takes you an hour to get there, right? Then your average speed is 50 miles per hour. Were you probably going 50 miles per hour the whole entire time? No, probably not. You were probably going much faster than that when you're on 77 and 421, and then slower than that whenever you're in Winston. Maybe there's traffic or something like that for it to be that low, right? So your average rate of change is 50, but that doesn't mean it was your speed at every point. So that's kind of the same thing here. The average rate of change is -4, but it's not the rate of change at every point. Okay. Time's so short. I need to skip something. I don't know if I want to skip this one or not, though. Let's do D. All right. We can at least get the average rate of change stuff done. That'll be good, and we can do part of the assignment. All right, so same thing for this. H of x equals this equation. We want to go from 1 to 4. No calculator on this. This is going to test your fraction skills a little bit. So if I want the y coordinate for 1, I would do h of 1. So that would be 1 plus 1 over 1 plus 6, which is going to give us 2/7 fractions. If you have a aversion to fractions, we're going to have to get over it because there is a calculator inactive part, and they sometimes will put some fractions on it. H of 4 would be 4 plus 1 over 4 plus 6, which is 5 over 10, which is 1/2. Okay, so this point right here is 1/2/7, and this point right here is 4/1/2. Okay, questions? You might be tempted to switch to decimals here. It's a big temptation, but if this is calculator inactive, 2/7 is not going to be an easy decimal, right? So fractions is what we've got to stick with on this one. So if I want to do the slope, I will do 1/2 minus 2/7 divided by 4 minus 1. I might want to put some parentheses here so I don't get things mixed up. Now I can't do 1/2 minus 2/7 because I don't have common denominators, right? What should I use as a common denominator there? 14. So that means I got to multiply this equation, this fraction by 7 on top and bottom, and this one by 2 on top and bottom. So that will look like this. I will have 7 over 14 minus 4 over 14. And I'm going to go ahead and just 4 minus 1 is 3 right here. So that is going to be 3 over 14 divided by 3. Oh, what do I do with that?
Turn 3 into
You do like the bottom fraction to flip it and then
Yes, and to do that, I need the bottom to be a fraction.
3 over 1.
So I could make this 3 over 1. And dividing fractions is easy as pie. Flip the second and multiply. 3 over 14 times 1 over 3. You could multiply, but those 3's right there cancel. So you get 1 over 14. Whew. Little fraction exercise there for you. I won't make your make you raise your hand and admit it, but I usually find even in pre-calculus that some of my students are still really weak with fractions because, especially Math 3, we just let you use the calculator on everything because you can use it on your exam. And they taught, I need you to know this about fractions. They taught you how to do fractions in like 5th and 6th grade, right? It wasn't that hard, or they wouldn't have taught it to 5th and 6th graders. But it seemed hard then because you were 5th and 6th graders, and it was a lot harder to your brains that were not as developed. And so you didn't learn it well, possibly, if you're weak in fractions. And then they gave you a calculator that would do fractions, and you're like, I'm never doing fractions again in my life if I don't have to. But you have reached the point where you're going to have to a little bit at least. So if you're struggling with it, it's something we can work on. We'll just keep practicing there. Okay, example 2 is a graph. It wants average rate of change over the interval from -1 to 3. Okay, for graphs, you're going to look at where the x-coordinate is -1. That's this point right here. And where the x-coordinate is 3, that's this point right here. You have a couple options on this. You could do the coordinates. This is -1, 0, and this is 3, 4. So if you have the points -1, 0, and 3, 4, you can do slope formula. 4 minus 0 over 3 minus -1, which becomes like a +1 there. You'll get 4 over 4, which is 1. So that would be your answer.
Or 3 plus, what is that?
We're at here.
Yeah.
That's a +1. It was 3 minus -1,
Okay.
but that minus the negative becomes a positive there. Okay? Or if it's an easy one, if it's an easy graph to see, here's another easy option for you. Draw the line, find the slope. If you do rise over run here, it's up 1, right 1, up 1, right 1, up 1, right 1. So 1 is your slope. So you got a couple options on how to do that. Okay, questions there? All right, so you're going to be able to asked to find average rate of change from equations, from graphs, and also from tables, like we've got in number 3. And 3 gives it to us in context of a situation. So this table gives the life expectancy of U.S. females born in a given year. Find the average rate of change of the life expectancy of U.S. females born from 1850 to 2000. Okay, and you can see a big difference here. Life expectancy in 1850 was only 46.1 years, whereas 2000 were 81.8 years, getting almost close to doubling there. So, if I want to know the average rate of change between 1850 and 2000, here's my 1850 and 2000. So the coordinates for that would be 1850, 46.10, and then the 2000 would be 2000 and 81.83. Those other numbers in the middle are not going to matter. We just need to know those two in the range that it's asking us for. And so we're just going to do slope formula with this. If you see one like this with decimals, I'm going to try to put a calculator next to it. If I've forgotten, it's probably a calculator problem. So 81.83 minus 46.1 over 2000 minus 81.8. No, sorry. Minus 1850. Okay, so if we do that on our calculator, 81.83 minus, oh wait, gotta go back to the screen. 81.83 minus 46.1 is going to give us 35.73 over 150, which is going to be 0.2382. Like if this was a AP question you were answering by hand, you could do this, or you could call it 0.238. What you couldn't do is round it to like 0.24. That would be rounding off too much. Now it told us here to indicate units of measure. What are units of measure for this? Not just years. Years is going to be part of it. It's a weird units of measure. It's so weird. So here's what it is. All right, this was our change in Y. What was measured by our Y? Our Y on our, what units do we use for Y? Age in years, right? Age in years. Okay, so over this 150 years, right? The age in years, the life expectancy increased 35.73. That's age in years. What was the X coordinate measured in? Year of birth. So what this is telling us is that our life expectancy is changing at a rate of 0.2382 age in years per, I'm just going to call it per year. Year of birth is a weird way to say that. In a way, the answer to this is years per year. So what's happening is every year that goes by, the life expectancy for the age is increasing by 0.2382 years. So the life expectancy increases 0.2382 years every year is what's happening here. It's weird. But if you always do that, if you always take your units for your Y and divide it by your units for your X when you're doing a rate of change, it's always going to be the correct units for that. All right, we are out of time. So, that's okay. We're at a decent spot. This is not a terrible breaking point. I'm going to give you guys your assignment, but we are not going to do the whole assignment because we haven't really the whole assignment yet. So let me pass these out and I'll tell you which one I'm going to do. Let's see. One through seven. Do 1 through 7. Yeah, 1 through 7. So it'll be like about the first half of this assignment. So do 1 through 7 for me for your assignment tonight. And then we'll pick up and finish this up tomorrow and hopefully still be able to do 1.3 those ones.